Our first speaker tonight is going to be Andrew Poole, who is going to talk about Fluent method chaining in C#. So please welcome. Now, we realized when we got here, Andrew's going to be doing a bunch of live coding, and all the mics we got are handheld. So plan A is Andrew's going to talk loud. If the folks at the back can't hear it, plan B is I'm going to stand here like this. So if you folks at the back, if you can't hear, just kind of wave your hands or something, and we will figure it out. Please give a big welcome, Andrew Poole.
Hi everyone, I'm actually just going to show some different slides first. Bear with me, and I shall try and be as quick as I can. So I work for ClearBank. They pay for my train ticket, so in exchange I just do a couple of promo slides for them. So what is ClearBank? It's a new clearing bank formed in 2015. What do I mean by a clearing bank? Well, it's a bank that's connected to the main payment scheme. So in the UK, that's BACS, CHAPS, faster payments and checks. It's like a scale-up fintech bank. It's been profitable since 2022, and it's like a bank for banks. So as a consumer, you can't go and get a ClearBank bank account, but if you have a trendy fintech that needs access to the payment rails, then you can call our APIs rather than become a direct participant of those payment schemes, which is quite onerous. But so our customers are financially regulated institutions in their own right. We have two products, so agency banking, which is you use our APIs to make payments and receive payments, and then embedded, which is if you want to sell our account platform to people and like offer them banking accounts, you can kind of like white label our banking license, I guess. So that's like the embedded proposition. Built on modern technology. Obviously, since 2015, there's a chance for some of the technology to become quite legacy, but relative to the old banks, it's definitely quite modern. And I guess the purpose really was to try and break the link between growth in client volume and payment volume and the size of your operations team. So traditional banks, the more customers they get, the more payments they process, the more people they need to manage all those manual processes. We're trying to automate all of that away so that we don't have that link. Recently raised 175 million for global expansion. So yeah, that's kind of like European expansion, cross-border payments, that kind of thing. Rapid growth, lots of awards. What about software engineering at ClearBank? So we have made these slides a little while ago. It might not be quite up to date, but there's about 150 of us, engineers and engineering managers, about 35 teams, 14 hives. That's our stack. I'm just going to spin over that. Basically, anything that's in Azure, we can have almost without any hassle. Anything that's not Azure, then you have to go through the supplier process, so it's a real hassle. There's quite a few large-scale migration journeys, so like original monolith to many microservices, and probably too many microservices. I imagine you'll cover that kind of thing. Most of our recent projects are event-sourced, unfortunately with Cosmos and ChangeFeed, but there it is. We have teams looking at AI, teams looking at digital assets, trying to launch a stablecoin, and another team, like a data team, that's actually using a data lake to serve up useful products to people in the business. So that's pretty cool. What's it actually like to work there? Well, there's a good culture. Everyone says that. What do I mean? So it genuinely is quite collaborative, high levels of autonomy in your team, freedom to express your opinions and kind of make a difference, have your voice heard, that kind of thing. And we have like a weekly lunch and learn thing called Take It Easy, which we're trying to use that to like build a community and break down barriers between teams that can become siloed otherwise. Interesting, challenging domain. I've already mentioned some stuff, but like the weird and wonderful world of payment schemes and cross-border payment flows and liquidity management and all that stuff. So yeah, really meaty domain to get your teeth into. Good salaries and benefits, career progression options, like whether you want to be an individual contributor or an influencing contributor or management, like there's defined pathways for that stuff. Those are some of the tools we use, and yeah, flexible working, nice offices, regular meetups. I've raced through that because I'm aware that my talk is probably already too long, so there we go. There's a couple of links. So that's the ClearBank website. That's our like recruitment microsite. Even if there are no roles there, if you are interested, you can email careers@ClearBank and or that should probably say come and talk to me afterwards. So that is my ClearBank slides done. And I'm going to quickly race over to this. Can you hear me all right, by the way? Yeah, cool. Okay. So, yeah, I'm going to talk about Fluent method chaining in C#. So I'm going to start with a question. And the question is this: have you ever found yourself looking through one of your repos and thinking, how on earth did it get this complex? Or does it really need to be this complex? Or maybe, how am I going to explain this to a new starter? And now, even that can come in two flavors, because you could have someone who's completely new to software engineering and you're like, oh my word, I've got to explain all this to a new starter. Or maybe it's a senior and you're like, oh dear, I have to explain this to somebody. You get what I mean. But presumably, projects all start out greenfield. You've got nice, clean intent and kind of design ideas and almost like production values, whatever. But sooner or later, you can get this accidental complexity that just seeps in, and for a number of different reasons. Maybe original team members who had some of the original thinking, they leave, or new people come in with different ideas. Perhaps you cut some corners, or the business want you to go in a different direction, or perhaps you just haven't got time and you go in and you change one little thing. And really, you should take the opportunity to do some refactoring, but you don't, and then it's confusing when somebody goes back. I'm sure you all know it's kind of like thoughtlessness, really. But I guess my point is, if we're not really careful, the intent of the code can get completely lost. We're left with something that's hard to understand and hard to maintain. So this talk, I'm hoping to kind of take you on a journey of that my team and I have recently been on, actively trying to solve this problem or avoid this problem. So quick caveat, I'm not saying everyone here should do what we did, definitely not. But hopefully I can kind of inspire some thinking about the way we approached it, and you'll find it interesting. Because it's quite a long talk and I need to make sure I don't take too long, happy to have questions at the end, but probably leave them to the end if that's all right. So one more little bit of waffling before I properly start. So I talked about international expansion. Imagine ClearBank has a presence in the UK jurisdiction, but some of our customers want to make cross-border payments. So we build a cross-border payment product, but we don't have an instance in any other jurisdiction. So we use third parties to kind of do that bit. So people like JP Morgan, they have branches all over the world. They can do those cross-border payments. So that's all fine. We're serving that product to our customers, but we have to pay quite high fees for the privilege. Time moves on, we get some investment. We start working on a banking license with the Dutch National Bank. We've spin up some teams to integrate with Target 2 and SEPA Instant and SEPA CT in Europe. And people start thinking, oh, hang on, now we've got two jurisdictions, Euro payments at least, we ought to be able to kind of fulfill those payments ourselves on our own kind of network. And if we design something that can not only deal with two ClearBanks, but kind of N ClearBanks around the world, then, we can kind of grow and there'll be no stopping us. So that kind of cross-border payments, but where we have a presence in two jurisdictions, that's the context which our team was working. So we were tasked with, we have an API over here, we have some payment schemes over there. How do we do this journey to save some money on not paying JPM to do that work? So yeah, we have a user. Now it's not playing. Now I've ruined it. Right, here we go. We have a user. User initiates a request. I'm going to walk around a bit. And we have a request coming into our system. We might do some validation, and then we might create and persist an aggregate. So for that, we'll need a database, and in that database, we're going to have some domain events. And then we might call an external service, so perhaps like an accounts domain service. Let's check that the account exists, it's in the right state, and maybe it supports the right currencies. We'll make some decisions based on that data that we've just fetched. And at some point, we'll decide that's probably enough for us now during the synchronous portion of this flow. We'll call out to an external service, and that's going to continue the process. And at that point, we can return an accepted to our client to say, yep, please hold on, we'll get back to you, but we've accepted your request. So this is like our API bit. Meanwhile, the external service or services are going to do their job, and eventually we're going to get a message on service bus, which we're interested in. So we can then rehydrate our aggregate, do some more stuff, and then save an outbox record. So now we've got domain events and outbox records in our database. And then we have a third component which polls that database, finds the outbox records, dispatches them to service bus, and that's our bit done. So this is now the context of our service. And then just for completeness, another team is responsible for a webhook service, which then sends a message back to the user. And they've now got a smile on their face because their payment's done. So during that flow of the cross-border payments from the originating side and the destination side, we had about 3 of these. So we kind of, there we go, built them in the same fashion. So we've got 3 executables, we've got our API, we've got a background worker listening to messages, and another background worker polling for outbox records and dispatching them off. And so this is like a kind of anatomy of one of our services. And the context of my talk is really around this API request handler. So we started this work, we're iterating, we're doing stories, we're adding bits of this flow, and we're watching the code grow, thinking, we need like a nicer way to deal with that code. It's getting up to about 100 lines. But we didn't do a half-hearted job. We waited, we got some buy-in, and we kind of thought, let's do a decent job of this. Let's try and make something nice rather than like a half-hearted effort. So what we had already, well, we already had a kind of like onion solution architecture. So I don't have the diagram here. I'm sure everyone's seen it, but what I'm talking about is a domain in the core of the onion, which has like enterprise level concepts, value objects, events, that kind of thing. Around that is where our business logic lives, in a kind of application layer. Separate from that is the infrastructure layer, which is around the outside of that. That's where the kind of dirty client packages can go, separate from the business logic. And then the outermost and thinnest layer is those executables, those 3 executables. So I guess the point is, as soon as possible when they need to do anything, they call straight into application for the work to be done. So we also had minimal API, which we could have done what we ended up doing with controllers, but I think this helped a little bit. And we also had this concept of trying to avoid using exceptions for expected scenarios. So what I mean by that is, if the user gives us bad data, we code around that, we expect it. We write code to handle it, so we probably shouldn't use exceptions for something that we expect to happen. Because if we have exceptions, like in logs, it would be really nice if that was truly exceptional, like, oh look, that's something we didn't expect, not just, oh yeah, bad data that we knew we might get. So for that, we're using the one-of library. Any fans of the one-of library? No one. Oh wow, normally some or even all. Oh, that's cool. Okay, so I'm going to head over to Visual Studio. So I don't have ClearBank code here, but I have an adulterated version of the file new weather report API, which we all know and love. Visual Studio file new project. So I've got my program CS here, and I've got here, I can probably zoom in a little bit. Can people see that? Yeah, cool, okay. So I'm mapping a get endpoint to v1/weather forecast / for a given region on a date. So the idea is we're going to try and find or generate a weather report for that region on that date. So I can get the region and the date from the root, using from root. And then there's this handy from services attribute, which we can use to kind of rummage around in the IOC container and find something that can handle this method for us. So we'll come back here in a minute, but if I go to that interface, I'm going to have to zoom out a tiny bit, or maybe I'll go across a little bit. So yeah, we've got handle get weather report. We take our region and our date in, and then what we need to return, and I'm going to say this about 1 million times tonight, is a task of one of weather report response or failure, or T success and T failure. So it's a task because we're going to be doing asynchronous work, and then the thing that we're going to return inside that task is a one of, and then these 2 things. So what one of does is it gives us discriminated unions in C#, even though we don't have unions as first-class citizens. Now there's a fairly well-advanced proposal now for unions in C#, so one of these years at .NET Conf, they'll be saying in what's new in C#, unions. So I'm really looking forward to that, because although one of is great, it's quite ceremonious, you might see in a minute. But the idea is this one of, the thing inside it can either be that or that. Can't be both, can't be neither, has to be one or the other. So gone are the days of like bool result and then string error if it's false or whatever. Now it's either one of those or one of those. And so when we call into the business application with our requested region and our date time, what we're going to get back is a weather report response if all was good, or a failure if something went wrong. Now you might ask, what is a failure? So let's have a look at that. So in this case, a failure inherits from one-off base. And there's these 3 at the moment, but you can have as many as you like, different failures that are encapsulated in my one failure class. So this failure can either be an invalid request failure or an unsupported region failure. I mean, this example is highly contrived, but you can imagine defining all of the different ways your application can go wrong. And now we have a way for our application code to return a result to the API in this case, without having had to throw exceptions. So if I go back to program, I've got this method here. I think that's probably enough of it. Create response for. And that accepts like a delegate, which is going to return this task of one-off T success or failure, such that we can kind of wire it up here. So we're still calling our handler, pass in the region and the date. That gets passed through to create response for, and then when it gets invoked, we have this result. And the result is, we've awaited it, so we've unwrapped the task. Now it's just the one of T success or failure. And we can use this match method, which is part of the one of library. And it's quite cool. So if I comment that line out, I'm going to get a red squiggly, which I don't know whether you'll be able to see, but it says method match has 2 parameters, but you've invoked it with 1 argument. So it's not happy unless I give it an argument for all of the different options in the union. And these variable names don't matter. It could be 1, 2, or discard or whatever. It's just the order. So with one of, it's all about like T0, T1, up to like T40, I think it is, with the extended bit. So if this first case matches, I now know that this is the weather report response, and I can just wrap it in an OK and send it back to the client. If not, it's a failure, then I can do a secondary match, and then depending on the type of failure, I can decide what to do. So invalid request, I can turn it into a validation problem details and wrap it in a bad request and send it back. Unsupported region, I might wrap in an unprocessable entity. So the application's returned a little signal for what's happened, and I can, right on my very edge, decide how to figure out what HTTP response to send back. So with that, I'm going to head back to my slides. So yeah, what about refactoring options then? So we considered a few different ways we could have taken those 100 lines of code. Now we could have just abstracted it into a few more classes, kind of thing we all do all day, every day. But and I guess that would look like await a method on a service, assign the result, check the result, decide whether to return, rinse and repeat like quite a lot of times. Would have been perfectly fine, but I guess we were just holding out for possibly something a bit nicer. So we also considered mediator. Now that would have given us like a really decoupled chain, which in some ways is very nice, but we looked at a couple of repos in ClearBank that use mediator, decided it's actually pretty hard to navigate. So to know what happened, or to know what's going to happen next, you've got to go and find the command, then go and find the handler for the command, then find the code that happens there and see what command is created next, then go and find the handler. It's a lot of searching. It's not very quick and easy to kind of navigate around. And we also went quite far down the road of a thought process around domain-driven design style internal domain events. We probably had a few problems with our domain model, which meant that we didn't do that, although we did come full circle in the end, and we have got internal domain events, which I'll mention later. So I also had this kind of niggling past influences / inspirational thing. Don't know if many of you recognize this. This is a piece of Windows Workflow Foundation. Anyone, any fans or haters? Probably, yeah. I quite liked it, to be honest. This is like a Marmite technology of the 2000s, but you have this kind of canvas here. You had a toolbox full of built-in activities, and you could just inherit from code activity, I think, to create your own, and then your own would just pop up in the toolbox. You could drag them on. This is probably a code activity because they couldn't be bothered to create a WPF piece of UI for it. So, but the nice thing about this is the flow is immediately obvious. It's like there's the kind of sequence flowchart version. I think, well, there was like a sequence version. I think there was a state machine and also a flowchart like variant. But all of them are pretty easy to understand. and they're quite functional. Like, unless you get something really wrong, your activity is going to be quite small, a nicely scoped name, very well defined inputs and outputs, and yeah, that made it quite functional, and also quite easy to onboard new team members, because a new team member didn't have to understand the entire system. As long as you can give them the flow and say, hey, can you create another activity which is like this one but does a slightly different job, or can you go and fix this problem with that activity, they could get started without having to get to grips with the entire repo. So there are definitely some things around Windows Workflow which struck me at the time, and I thought, yeah, that's quite cool actually. Trying to host the designer though was not one of them. That was not fun. So I guess all of this led to a set of aims. We wanted to declaratively define a flow of tasks in a single place. And I suppose that meant moving the complexity down so that you can see the wood for the trees in a way. We wanted to maintain that kind of functional approach. We wanted whatever we did to be easy to navigate, debug, and certainly like no harder to test than anything else, for instance. And I guess in a word, easy to grok. So I had to look up this word to see whether it was still a thing, because it's a pretty old word. I knew that. I knew I'd heard it somewhere, and I thought, I think that's what I want. And I found this amazing dictionary definition. It's quite long, but this is like the start and the end. So to understand intuitively or by empathy, also to experience enjoyment. And coming back to do this talk, I was like, yes, that's exactly what we wanted to do. Now, incidentally, grok is the only word in the English language which is derived from Martian. And it was coined for a novel called Stranger in a Strange Land in 1961. So there you go. I think to explain some empathetic way that Martians were able...
Martian, it literally means to drink.
To drink? Oh, I should have known you would know.
That's what I'm here for.
So let's go back to the code. I'm just going to grab a sip of Coke.
It's a very good book as well.
Is it? Yeah, I must... I've mentioned it so many times, I must actually read it. So back to our get endpoint. So if I, actually I'm going to go straight there this time. So I have here my get weather report request handler. And this is an example of what we didn't want to do. So this is the flow we want to represent, but not the way in which we wanted to do it. So we want to validate the region, await it, assign it to a result, check the result, decide whether to return, then check the date, and then check a cache. If we get a hit, we'll return the cache data, otherwise we'll generate some new. So what did we actually come up with? If I just collapse this. This is what we came up with. So hopefully, after a few seconds of just staring at that, you don't really have to think too hard to see that that represents almost the same flow. So there's a couple of things about this. There's only one return keyword. So I'm not having to decide to return in loads of places, which makes it really quite terse and kind of, I don't know, I really like it. I was quite excited when we kind of stumbled across this. So you might notice the cache is missing. We're going to address that in a second, but it's all centered around this weather report details, which is kind of like a container for state and also represents success. So I've got this static create method, which is going to take my region and my date, and it's going to return a task of one of weather report details or failure, but because it's the first thing in the chain and I know, it's definitely going to be a weather report details because there's nothing happened to have gone wrong by that stage. So then it gets passed down into these methods. So yeah, what's actually going on here, I'll do this now. We get a details passed to us, and then that is being passed into these methods. But the compiler is basically saying, if there's only one method, one argument, and it matches the thing that you've been passed, then you can do method group conversion, and you don't need that like extra ceremony. So the most important thing for these methods to do, in order to be chainable, they just have to return that task of one of T success, T failure, and then they can be chainable. Doesn't matter where they come from. And they should do their job, and if it's successful, they need to return a weather report details. They can mutate it along the way if they want to, but that represents success. Otherwise, they have to return one of those failures that I showed you. And then in the extension method called then, which we'll go to in a minute, the first priority is check what we've been given. Was it a failure? If it's a failure, we don't call the next delegate, we just cascade it straight down through the chain. So that's why we can have the one return keyword. If the success goes all the way down through the chain, then it just gets turned into a weather report response, which meets the interface that we've been asked to meet, and then the flow is complete. So I've got here a little contrived check cache method. So let's add that. So I can just do check cache because again it's method group conversion. What if we needed an additional argument? Let's say we need a string called settings. Well, that's fine if we have one. Let's just do var settings, give it some dummy value or other. So now we do need to do the full version. And then when we call check cache, we can just pass in D and settings. So we can do anything we can do with an ordinary method. It's just a C# method. There's nothing special. The only thing it has to do in order to be chained is return the right type, which in this instance is that. So we've checked our cache. We don't want to call generate if we had a cache hit. So there's a slightly different version of the method which takes an extra delegate. So if I say d dot populated from cache equals false, so we didn't find it, in that case we'll call generate. Otherwise we'll assume that that data has been populated inside our details, and there's no need to call generate. So with that if then, no failure has occurred. It's still going to pass the success down. It's just that if the condition isn't true, it won't bother running that particular next job. So you can see we can kind of express a small amount of control flow logic in the top level as well, which is quite nice. Yeah, okay, let's have a look at the actual method then. All right. So I'm going to have to zoom out, apologies. So this is the simplest version of then. There's quite a lot going on in here, and as you can see, I've done my absolute best in / comments to explain it. But if we take it down step by step, it's not too bad. So the name of the method is then. We've got two generic types specified here. We've got the all-important task of one of TS and TF. So I've abbreviated success to S and failure to F, just to kind of make it, well, as much as anything else, to fit on the screen when doing talks. But so this is a old school extension method. Obviously in C# 13 now we've got many new ways to do extensions. So who knows what opportunities that's going to open up for the library. But so we're actually extending the previous job result, and it is literally just the task of one of TS or TF that we just had. And then the next job is basically a func where you're passed the success from the previous link in the chain, and you guessed it, you have to return a task of one of TS or TF. So the way it works then, we'll await previous job result, which in most cases has already been awaited here, previously in the chain. But because it's full fat tasks, we can await it multiple times, and if the result's already available, there's no cost. Value task, it isn't kind of supported. I'll come to that later. So we can await that. That takes the task off it. We've now got our one of T success or T failure, and then we can use this is T1. So is T0 would have told us if it was successful. Is T1 will tell us if it was a failure because of the order of the items in the union. If it was a failure, we just return that straight away. That's like number one priority, always. If we receive a failure, we cascade it. Otherwise, we'll do as T0 to kind of peel out the success thing from the one of, send that into the next job delegate and return it. And then that's how the chain carries on. So there's a few more variations of this method. This one is the same, but it has an on failure delegate. So exactly the same. If we got a failure, we must return it. Otherwise, we will get the current success, pass it into next job, but this time we get the result and we evaluate that result. If it was successful, we can return it, but otherwise we'll call this on failure delegate, and that gives you an opportunity to kind of tidy up something that you've just done. So imagine you have a chained method which creates a cache transaction or a pending transaction, and then in the very next step, you do something else, but it immediately goes wrong, and now you want to tidy up that cache transaction because you don't want it like an orphaned one. this on failure delegate gives you the opportunity to kind of go and undo or like do some tidying up, and it can return return a new failure as well. With me so far? Yeah, cool, lots of nods. So then we've got the if then, which I showed you. So the difference here is that we have an additional func here. So it's going to pass you the T success, and it's going to expect a bool back. And if that evaluates to true, then it will carry on. So again, always return the failure first. Otherwise, evaluate the condition. If it's false, then we can return straight away. Otherwise, if it's not, we can evaluate the next job, but we'll catch the result. And if we need to, we'll call the on failure. So you get the idea. I've got a then for each, which allows you to provide a func for like a collection of items that you want to perform a task for each one. And there's to result, but I'm going to skip over that one because it's a bit boring. And then somebody challenged me, what if I wanted to do some tasks in parallel in the first time I did this talk? And I was like, oh, that's such a great idea. So I went away and I made some parallel methods. So I'm going to skip over these two for a second, then wait for first. So I'm using params, and again, params doesn't have to be an array anymore. So again, cool stuff in C# 13, but yeah, I'm using params so that you can just do comma, call this method, comma, call this method, comma, call this. It's really nice to work with. And it's pretty easy. It's as easy as doing a task when any, and then whichever the first one that completes, I can return that result down through the chain. So that's fine. But then wait for all is slightly more hairy, because there is, if you think about it, there's absolutely no way my library can know how to merge the results of your list of tasks, which could be doing anything in the world. So there's like a kind of naive default merging strategy here, but you really need to provide your own here. So definitely, if you want to use that, be careful. It's all unit tested. I know it works in the way that I intended, but yeah. So yeah, that's it for the extension methods. There's another class with the exact same methods in, but all with cancellation token support as well. Yeah, I'm going to go back to my slides. Hopefully I'm not doing too badly for time. Yeah, cool. So our answer then to this problem was the combination of a generic extension method, the returning of the one-of, the object that represents success that's passed down through the chain. Any method which returns that task of one-of T success or failure can be chained. It doesn't matter whether it's like a local method or an anonymous method or one off a service that you've brought in from IOC. Anywhere, as long as it returns that, you can chain it. And then, yeah, the main thing to remember is next job is only invoked if what you were passed was a success. Otherwise, if it's a failure, it cascades down through the chain. That's how we can do the single return keyword. So I made this piece of code to stick on LinkedIn as a little teaser for the first time I did this talk. And obviously highly contrived. So let's create an instance of a meetup attendee. Then we'll drive to the event. If feeling hungry, we will eat pizza, passing in our favorite flavors. Then we'll wait for the first of either a full stomach or we run out of pizza. Then we will learn stuff and ask questions. Then we'll chat with new friends and drive home happy and hopefully inspired. So it's amusing, but what I'm trying to demonstrate here is like the intent is now the star of the show, and I can like write a little story. It's quite English-like. And I don't know if any of you have seen David Well's talk called Minimalism in a World of Dogmatic Design, but it's on YouTube in a few places. Really, really amazing talk. And he has this quote. I don't think it's his. He's paraphrasing, actually. But code is literature. It's an expression of intent communicated between developers. Incidentally, it happens to be compiled and executed by machines. And it's a paraphrase of a statement that Harold Abelson wrote in a book in 1983. But this really hit me between the eyes. Like if you've written some code and popped it into production and 10, 15, 20 years later it still hasn't had to be touched and still doing its job, great, well done. But for the most of us, code needs to be nurtured, it needs to be looked after, it's got security vulnerabilities and packages need to be updated. The business can't decide what it wants, it needs to be changed, and also the team is changing under your feet as well. So it could be me in 6 months, it could be a completely recycled team in 3 years, and the easier we can make it for other people to understand our intent in the code, then the easier that piece of code is to live with and to kind of keep alive and hopefully less likely for someone to come along and say, I just want to rewrite it, which is, let's face it, what most of us always want to do. So yeah, turns out this is also the chain of responsibility design pattern. There's a cool website, Refactoring Guru, that explains lots of design patterns. There's a couple of other examples, like Mediator is another example of this as well, only goes about it a bit of a different way. There's also a package called Fluent Results, which somebody brought to my attention, which achieves a similar result, but it's more like die-hard, mathsy, functional. So its syntax is more like .bind. It doesn't make so much sense to like as English. So I'm sticking with mine. Yeah, back to the code. So the next piece of the story, orchestration. So I'll go back to the program. Not content with serving up weather reports, we are now going to enable some of our enthusiastic users who might have a weather data station thing bolted to their roof, allow them to post collected weather data to us, and maybe we'll pay them for the privilege as well. So I've got this post endpoint here. I can get the location from the route. I can get the data from the body. And then in exactly the same way, I'm going to find something that can handle this request for me. And then I'm also grabbing a couple of other services and kind of injecting them in for reasons which I'll hopefully remember to explain later. But let's go and have a look. So bearing in mind we're at the API definition here, I'm going to do one control F12, and that's going to bypass the interface and go straight to the implementation. Hint, hint, it's quite easy to navigate with this kind of thing. So here we go. Here's our API handler for the beginning of this process. So it's changed a bit now. I'm doing validation outside of the flow, and that's because we had a load of problems with that details thing. We had several flows and we were reusing that details object. It went through several iterations. It became a completely immutable record at one point with some nullable types that started life as null, and then we used the with keyword to populate them later. But what we found was you still needed to know which flow you were in to know which properties you can safely, reliably use, which was rubbish. Like for the rest of my team, I bared with it because I thought it was really cool, but it was bad. So what we eventually ended up doing was basically going internally event sourced. So we've now got an aggregate. The idea being that if something's happened in real life, that's now a fact. So there's going to be a domain event somewhere in the database which represents that fact. Every time we handle a message that pertains to this particular aggregate, we'll reload that aggregate into our, essentially into a in-memory collection of domain events, and then our properties. So this weather data collection thing now is actually like an aggregate root entity. It's got properties that all are populated from that internal collection of domain events, and you can't add them, you can't set them. The only way to set them is to save a new domain event, and then once it's round trip to the database, we know it was successful, we then update the internal collection of domain events, and we know our state will be consistent only once it's already gone to the database. So I don't have time to go into that now, but that was one part of the evolution of our story. So we're now going to do the validation first, because we don't want to persist an aggregate if the data wasn't valid in the first place. If it was valid, we've now got this persist or hydrate method. Now there is a bug with this, which I noticed when I was going through it earlier. We shouldn't be doing a new GUID here every time, but let's leave that alone. So the idea between persist or hydrate is, if this is the first time we've seen this request, we want to persist the beginnings of a new aggregate. So that's where we've got this event.create weather data collection initiated. That's like the first event that's going to be persisted. If something goes wrong in this flow, we're going to come around for a retry. In that case, we should basically just rehydrate the aggregate from the events that we already have, so that we don't end up redoing steps that were successful. We just carry on. For instance, where this might be useful is, let's say a payment came in for an account, but the account's closed for some reason, and you get like a dead letter. Meanwhile, operations decide, oh, that account shouldn't be closed, let's go and open it again. Now you can replay the dead letter, we'll rehydrate the aggregate, this time it's going to check the account, and now it's open, it can carry on. So yeah, persist on the first go, but possibly hydrate if we're in a retry. And then we've got the same kind of just like flow here. So we've got concept of some kind of location manager that's going to look up an ID or create a new one, and then a weather data modeling service. So what I'm trying to demonstrate here is that bit in my animated diagram where we call out to an external service to carry on the work for us. And that's then going to stick a message on service bus, and asynchronously we're going to carry on. So at this point, when we submit, like I'm imagining a Met Office supercomputer down the hallway kind of thing with a REST API though. We're going to submit our request to that. That's now our job done. So we'll return like an accepted or something, and then we're just waiting for the message handler. So what we then realized is, because this is an application, there's absolutely no reason why we can't co-locate the handlers, the message handlers, in the same class. So what we've got now is basically the whole flow. So we handle this API request in the first place. We then submit to the modeling service. We're then going to get back 3 or up to 3 events. So we might get model data accepted integration event, which says, yes, the data's good. I will add it to the model and then let you know. Or we might get modeling data rejected, which says, nah, there's something in that data that I can't work with. And then at some point later, we'll get model updated to say, yes, that data is now incorporated and it will be available for weather forecasts or whatever. Like I said, this is all very contrived. But so yeah, I did say we would add the ability to pay people. So let's just quickly add in one of these. Let's add a, oh, hang on. Oh. Oh, I don't want to do this manually. Wait a minute, I've put it in the wrong place, haven't I? Bear with me. There, I wanted to put it there. There we go. Let's just add a read-only field for this. Should have moved primary constructors and it would have been easier to notice. So we've got our contributor payment service. So let's say once we've located, we've figured out the location thing, then we can just do contributor payment service dot create. Then we're going to submit the weather modeling thing. What if we got a bad request straight back? Well, we could use that on failure thing. So we could say details and failure. And now we can do contributor payment service dot revoke. Oops. And we just need to pass in the details. And let's stick that on the next line because it'll look nicer. And then we'll get the comment and pop it back up there. So still going to do our like asynchronous call out to an external service. But if it goes wrong, we can immediately undo the thing that we just did. So that's an example of the on failure delegate. So when we get model data accepted, we can now say, great, it's all good. Let's pay the person. So contributor payment.commit. But if we got model data rejected integration event, then we should also revoke it there. So maybe the API thought the data was okay, but once it inspected it a bit more deeply, then there was a problem with it. Dot revoke. Cool. So interesting thing here. This code is from one executable, which is a background service listening to messages. This code is from a different executable running as an API, but because we share the T-success, we can get some like reuse out of these methods quite nicely. So there, is that process kind of fairly, like the flow, fairly clear? So the idea is this is now like a vertical slice from start to finish. How did it start? Well, we received an API request, sent off to some external service. Then we handled a service bus message. Maybe it goes off to another service. Maybe there's a few things in here, but we can kind of express an entire flow, which if you were talking about the logic inside your own service, you know, you could dumb down the logic into a diagram for a refinement session, or as long as you get the names, the method names right, you could just look at the orchestrator in your refinement meeting. Like, it's not that hard to understand. So, right, what else have I got to do? Got to be quick. So I did say it was no harder to test. So I've got here what we call a component test at ClearBank. So I don't know if other people use that word, but think rather than the unit being the smallest unit of testable code, how about the largest unit of testable code? So I don't just mean all the services that I can use, but what about all of the executables all in one context? Let's mock out service bus. We've got a test fixture which is going to run up a application test host factory for each of my 3 executable apps. And so when I call the servers are started, I'll just quickly show you. Oh, sorry, 2, not 3. So I'm going to start my API factory, I'm going to start my event listener factory, and we've got these helper methods which again just make the code a bit more English-like. So given we have some collected weather data, and then also out variables. I really love these now. I can define this thing in line. Like, out variables are a bit old-fashioned, aren't they? But in this context, I think they really work. It's like, why would I want to define this up here somewhere when it's used here? I can see exactly, and I can click on it, and yeah. So we have some weather data. The modeling service submit endpoint will return accepted. So anything on the given, which is configuring a service, is like future tense. It just makes more sense. And then the servers are started. Then I get into my when, which is like my kind of like act of arrange, act, and assert. We wrap the collected weather data in an HTTP request and then send it to the API. So we're mimicking the client there. And then all of my assertions are in then. So I can make a few assertions here. So the submit endpoint should have been called one time. Internal domain event should have been persisted, called submitted to modeling. I should have got a OK back, and the body should not be empty. And not only should the body not be empty, but give me a deserialized instance of that body here so I can use it later because I need the request ID. So that's like the first phase. Then we can go and simulate, so like when a message appears, so that's me saying, oh, here's a message pretending to be from the modeling service. And then I can do a second assertion to say, yep, we should have a modeling data accepted domain event. And then finally, in like the last phase, I can simulate the model updated integration event and assert that we should have got model updated. So I'm going to quickly run this to prove to you that it works, and then we'll quickly debug it after that. And I'm going to have a sip of Coke. Okay, so it passed. Let's debug it quickly. So it's going to first of all break on program CS for the API. So you're not going to be able to see this, but that says examples web API up there. So that's telling you that it's running up the program. So by the way, that is the entire IOC, all of the configuration in program, and yeah, all of the configuration that you need. Like if I take a piece of config out or I forget to register a service, this test fails straight away. So it's quite cool. Hit F5, here it's going to hit run async on the event handlers project. Next time it's going to break in the weather, the locator thing. So I should have had another breakpoint, but it's not hard to debug, but you don't want to get stuck in the then extension method. That is not fun at all. So you have to stick your breakpoints in the chain methods, and then you're just debugging as normal. So the next, we've zoomed right down to the bottom of the test here, and I'm going to step into this method. So, and another cool thing about these helper methods is when you write one of these assertion methods, it's not just a throwaway piece of code that's only going to be used in one unit test. It's like there's a purpose to making this thing as nice as possible, because then I'll want to reuse it more. So we have a generic thing here, so I can like get the type of T, get the event class name, which is, you can't see it, but it's model updated. And then in here, I can go into my, so there are still some things which are mocked, and the database connection is one of them. So in my event repository, which is the real thing, the underlying database connection is mocked, and I can see in my persistent events, 6 events here, and the bottom one is model updated. So that's the one we're looking for. So that's why the test passes, because all through that process, in all 3 stages, we're saving those internal domain events, and I can just assert that they're there. So hopefully that demonstrates that this is no harder to test than anything else. Yeah, cool. Right. So we can define related flows together. We can get a bit of reuse out of some of our chain methods as long as we use the t-success, which, matching t-success. Only significant things in the top level flow. So this was an interesting thing I came across with my team. They kept putting interesting things in the chain methods, and I was like, nah, put that in the top level flow. Like, people deserve to know about that. That's an important thing. But I guess you could also take it the other way, and you could put so much stuff in the flow that you lose the wood for the trees. So like some discretion needed. Like, what things are significant enough, to go in that flow. Testable, that was just to remind me to go and run the test, in case I forgot. Oh, hang on. Yeah, okay. So yeah, benefits. I think it's now easy to reason about either the entire system or at least the entire vertical slice. Questionably, like I mentioned, better than a diagram for a meeting. Obviously, if your meeting is about like many of these systems integrated together, then yeah, you're still going to need some diagrams or documentation. But accessible to non-technical people. Now, I had a product owner who was constantly confused about what components are doing what, and I'm like, why don't I just show you? And he's like, oh no, I don't want to see the code. I'm like, yeah, come on, just have a look. And he's like, oh, actually, I can see what's going on there. Now, I don't know exactly what it's doing, but I get the gist. And he said, can we use this more? And I'm like, well, yeah, we just invented it, but yes, please. He said, could I tell some of my product owner friends about it? So I was like, please do. So yeah. Another interesting thing. So we are internally event sourced. So we're still integration event driven on a system level, but internally we're event sourced, but not event driven, we're flow driven. So the flow is defined in that one place, but there's still event sourcing going on in the background. And the cool thing about that is you don't have that, like, I love event sourcing, but one of my little pet peeves about it is events are rightly in the past tense. It's like, this thing has happened, go and find the handler. How do you know what happens next? You still have to go searching all the way through. Whereas in this way, here's the whole flow. Like, this describes what's going to happen. So yeah, interesting difference. So somebody asked me about performance, and I thought, oh yeah, that's probably a good thing to check. So I created some benchmark.net tests, and the bad news is it's like twice as fast, twice as slow, no, half as fast. I don't know, whatever that is. But a nanosecond is a billionth of a second. A microsecond, so like if you were comparing 0.4 to 1.4, is a millionth of a second. So I would argue, if you're going to call an API, if you're going to hit a database, send a log, almost anything, you're not going to be worrying about microseconds. So like, the performance is negligible. And I think the trade-off is that you get nicer code to look at. So I think it's worth it. There's some limitations. Mentioned those parallel methods need a bit of care. So it only works with full fat task, and that's because I value task source. The interface is kind of pooled to reduce allocations, and if you await a second time, it will just throw. But I think I'm okay with that, because value task is for scenarios where you're pretty sure the result's already there. And I'm using this to kind of orchestrate async stuff mostly. Care needed when managing dependencies for orchestration. So yeah, if you're not careful, all the things that happen in that orchestrator, you need a lot of dependencies in the constructor injected for that. And you might need things that are only really needed in event, like your message handling. Suddenly your API needs those, or vice versa. And that was why I fetched those extra services and injected them in, because from the API you can do that. With my message handling implementation, it's just like handle a T. You can't pass extra things in. So there are ways around it. You can have two classes in one file, so the code's still next to each other, but they're in different classes. Especially with primary constructors, it doesn't even look that ugly anymore. So conclusions. Did we succeed in our refactoring effort according to our aims? I think we did. Hopefully you agree. Am I advocating the use of this for everyone and everything? No. But it is worth considering the benefits of easily understandable top-level code. And I was challenged to kind of come up with, how would you sell this to non-technical stakeholders? So I've mentioned most of the stuff. It's easy to read and understand, so you could argue it's less time spent context switching, faster to onboard new people, and you could contrive a potential cost-saving calculation, although I'm not sure. easy to use. So yeah, hopefully you'll agree that I've shown that it's quite easy to navigate, fine to debug, and it's easy to test. So therefore it's kind of easier to live with, easier to change and maintain. The lower impedance thing, that's more about, product owners and business analysts being able to look at the code and it not being completely like foreign to them. And then yeah, I'm going with happy engineers because I don't know about you, but if I get to write elegant and intelligible code, it makes me happy. So, hang on. Yes. And now the twist in the tail of the story. So we spent about 2 years, our team, on that cross-border payment stuff. We got quite far and we got to the point where they wanted it delivered faster. So we got a new team and we'd been working on this kind of like outbound flow. We got a new team and they put in the outbound return flow in less than 2 sprints. It was all going really well. But what snuck up on us was the fact that because this was a new service, there were about 3 kind of fairly large business decisions that we needed making. And because it's a new service, the various people of the business, like the treasury, the operations people, and the FinCrime model management, or whatever they are, they all said, "Oh yeah, we want you to use this new thing." We're like, "No, we don't know how to integrate it with Dynamics. We just want to put you a page in the portal." No. Dynamics is the new thing. Treasury model, we want you to suddenly start doing double entry bookkeeping when that's not our domain. Go and talk to the transactions people. And anyway, there was all of this, what should we say, lack of consensus, which was just grinding us to a halt. And then a big decision was made to exchange all of those external difficulties for a bunch of technical difficulties inside the team. So basically what we did was we threw it all away and we went back to the old multi-currency thing that I told you about in the first place. And we've just started again, reusing all of that stuff, and we're just now in another provider, and it's pretty painful, to be honest. So that leaves me with a bit of a dilemma around, do I continue to talk about this? If you ask me, is it live? I have to say, well, it's in production at the moment, but it's not live, and it won't be in production for long because the team are ripping it out as we speak, and they've started again. And yeah, but I still believe it's interesting. I still believe the journey was worthwhile. So I am still talking about it. But yeah, so that's it. My NuGet package is here. All the code I've shown tonight is there at that GitHub repo. There's a couple of places you can read a blog I wrote about the chaining bit. Yeah, any constructive feedback about my talk would be greatly appreciated. And thanks for having me.